All right, so in this video, what we're going to do is look at we have water flowing in and out of a container that contains a salt solution. And we have an initial salt solution, and we have a more heavily concentrated solution pumping in, and we have the amount of fluid going in at the same rate as the fluid is coming out. So this means that there's always going to be the same amount of fluid in this container, even though the concentration is changing. And based on the problem, and I encourage you to pause the video if you want to just get a full read of the entire problem. There it is there. So give the video a pause. We'll be here when you get back. All right, so at first we have 100 gallons of a salt solution containing 0.25 pounds per gallon. So that's this passage in red right here. When t equals 0, and what it ends up being is 25 pounds of salt. So it turns out that this problem is most easily solved if we let y be the number of pounds of salt in the tank at time t. And our goal is going to be to find a formula for y. So this is what's modeled by a differential equation. And what we're looking at is this idea, is that dy dt, which is the rate of change in the amount of salt in the tank at time t, is equal to the rate of salt going in minus the rate of salt going out. Now, the thing to keep in mind is units are so important. Y is the number of pounds of salt in the tank at time t, which means dy dt is going to be pounds per minute. So let's take a moment and look at all the information here. So going into the tank, we have a 4 gallon per minute flow rate and a 0.75 pound per gallon. This tells me that if I set it up this way, 4 gallons every minute times 0.75 pounds per gallon, the gallons cross out and we end up with pounds per minute. So this is going to be 3 pounds per minute. So you notice, in short, all we have to do is multiply those rates together. As long as it's gallons per minute and pounds per gallon, we just multiply them together to get the overall rate of how the pounds of salt are changing. So that's 3 minus, now, the rate out. We have 4 gallons per minute going out, and at any moment, we have y pounds per 100 gallons. Because remember, the amount of salt in this container is changing at every moment. So the best we can do is say y. So this is 4 times y over 100, which does simplify really nicely to y over 25. I'm actually going to write that as 1/25 y. And then as for an initial condition, that's this piece of information right here. We know that when t is equal to 0, there are 25 pounds of salt, and y is the amount of salt. So we have y at 0 equals 25. So there we have that. Now, how to solve this differential equation. It is separable, so we could definitely use separation of variables to solve it. I'm going to go ahead and use the first order linear method with the integrating factor, just because most people seem to really enjoy that method more, as far as we can say enjoying solving a differential equation, right? So that means I want the dy dt, I want the derivative term and the y term on one side, and I want whatever's left on the right. And that is perfect first linear form. The coefficient of dy dt is 1. So that means that the integrating factor is e to the integral of whatever's in front of y. And that's dt because t is the independent variable. So we have e to the t over 25. And now we know that the solution of a first order linear has the form I times y is equal to the integral of I times q dt. I is e to the t over 25. Q is the function that's on the right. So that's e to the t over 25y equals integral of 3e to the t over 25 dt. And we know that that is equal to, just write this down here. So when we integrate e to the t over 25, we divide by 1/25, which means multiplying by 25. So that's going to be 75e to the t over 25 plus an arbitrary constant. And now we divide through by e to the t over 25, which means multiplying by e to the negative t over 25. And all of a sudden, there we have it. Now we know that y at 0 is 25. So that means 25 goes in for y when 0 goes in for t. So we have c is equal to negative 50, it looks like. Yep, that makes sense. Okay. So that means we have y is equal to 75 minus 50 e to the negative t over 25. And if we just examine that solution, just notice a couple things. Naturally, when t is equal to 0, we get the 25 that we wanted. And as t goes to infinity, this term right here is going to drop out because you have e to a negative huge number, which is going to be so close to 0 that we just call it 0. So let's think about that in terms of the information that was given to us. If I come back up here, this is the water that is going into the tank. Eventually, if we put in enough of that water, that concentration is going to take over whatever was there at the beginning. And notice that that does equate to 0.75 pounds per gallon times 100 gallons is 75. So that definitely does make sense to us here. So that is our solution. And we can also answer some other questions. Maybe you want to know when we reach 20 pounds of salt. You could just set this equal to 20. And there's all kinds of other questions you can answer with this equation. So there's our solution. Thanks so much for watching.